So here we are looking at rules of radical expressions. Let's try a couple. Keep in mind when you're doing these rules of radical expressions, you have up here, this is the cubed root of 98. So basically you're asking yourself, there is a number under here that will make this come out to, that will multiply towards 3. And because 3 is an odd number, there kind of isn't. 7 times 7 times 7 is not going to give you 98. So there isn't. So you're going to get an approximation. We all know those are those lines like that. But anyway, that's what that means, a cubed root. Same thing, 5x over x squared, and then you have this equation here. So when you look at things like this and solve this equation, anything that can be doubled by its, multiplied by itself, like this 3 and this 3, can be pulled over here outside of the radical sign. Do you see another a? No. So this a has to stay there. These two b's cancel out, so they come out of the radical sign. And then these two c's cancel out, but it leaves one c here. So that's how you got 3bc, and then the rest just stays under the radical sign. And that was done over here for you. So 3bc, and this is times the square root of 2ac. And that's as small as you can simplify it. We're not in calculus yet, so you leave it alone. Okay, and then you come over here. Here's a quotient rule. You can combine these two and make this whole thing like this. This was kind of done in these psychedelic colors here. And this then becomes 50 over the square root of 2. And when you go over here, 50 over the square root of 2 is 25. This was done here, but guess what? It's the square root of 25 because you can't remove the radical sign yet. But because 25 has a perfect square, which is 5 times 5. I'm sorry, I hope you see that dot. It's 25. Guess what? This is your answer. It's this 5. So this is the correct problem. So it's that easy, but please don't forget your quotient rules. Okay, now you have a quotient rule here. You have 25 over the square root of x. A lot of people are ready to go ahead and do this and go 5 over the square root of x, and you can do that, but we're forgetting a real simple situation that what's really going on is this is 25 over x with a radical sign there, square root sign, okay? So when you get ready to do this, if you want to get rid of it, you have to multiply this term, the denominator, by both sides of the equation. Okay, keep in mind that the reason you're doing that this square root of x divided over this square root of x is equal to 1. And in these division rules, this one is what makes you go over and take this over. So when you go across, you go 25 times x is going to give you 25x. Wow, that was badly drawn here. Okay, so then you're going to get x over times x is going to give you x. I'm going to go across here for this. Okay, so you have 25x over x. Are you done? Well, let's go on to the next slide. Okay, now you can now take things out of the radical sign, but here's the situation. This x over here is by itself, and if you look at the math, this is 25. This 25, sorry, is this 5 times 5. So they come out and it becomes 5 to the square root of x. It has to stay because it doesn't have a matching partner. And then it's under the square root of x. So that was right. Okay, you can rewind it. 4 times square root of 8 looks like it's easy. You know, a lot of people are already inclined to go 4 times 2 times 2 times 2, but guess what? It did not ask you for the cubed root. The only thing you can do, you could try to do 2 over square root of 2 if you want, and then do 4, but that's going to complicate things. Okay, let's make sure we get rid of this denominator in the right way. Okay, so you already have this here. Your denominator is given to you here, and it is the square root of 8. So you have the square root of 8 over the square root of 8. Okay, because these two equal 1. So now you have 4 times the square root of 8. Now we went straight across here. We multiplied straight across here. So you have 4 to the square root of 8 over square root of 64. Okay, stay tuned. See what's going on here. Let's take care of the top first. This now is 2 times 2 times 2. Now you can do that. And you come over here and you can take these two 2's out. And that becomes 4 times 2 over square root of 2, square root of 64. You already know this is going to be 8, right? Okay, let's go on to the next slide. Okay, now you have 8 to the square root of 2 over 64. But guess what? Can we simplify? Absolutely. 8 times 8, square root of 64 is 8. That's a perfect square, right? Because if you were to do your trees, you get 8 times 8 over here. So you have a perfect square. This becomes 8. Do you see what's going on now? Let's go on to the next slide to take a look at how and if we can reduce this. So when you go to the next slide, guess what? This 8 becomes 1, and this 8 becomes 1, and this becomes square root of 2. Great job. If you have any questions, here we are, Jacobitz Learning Group. Find us, Jacobitz Learning at jacobitslearning.com or kjacobitslearning.com. 12ab over 6bc. Can you cancel out like terms? Yes. 6 goes into this 12, and we did it over here one time. It goes into this itself 2 times, so you have 2 over a is left over here. What's going on? This b and this b cancel out. There is no other c. I'm putting a question mark here. And there is no other a. So we have that. So how do we take care of this now? Because we want to get rid of the denominator. Some of your teachers may allow you to keep it at 2a over c, but if they're trying to teach you how to take care of radical expressions, they really should have you do the square root of c over the square root of c. And that's what we're going to do. We're going to multiply it. Then we go on to the next step. We just go straight across and we combine this. And remember, once we're multiplying, everything becomes 2ac. If you have the square root of c over the square root of c, don't write 2, you have c. Because it's a square root, a square times itself is going to equal 1 because of your roots. So your answer is going to cancel out this square root bracket, and that's going to become 2ac over c. And that is going to be your answer. Okay, just remember what's going on, try to think it through, and remember once you cancel this. If you had the square root of 2 times the square root of 2, and you wanted to go out and do this, you would get the square root of 4. But we already know the square root of 4 is equal to 2. It's the same thing. Square root of c times c is going to give you the square root of c, which is then going to give you c. Same concept. A lot of students forget that. Please don't be one of them, because if you forget that, the whole problem is in wrong. Let's move on. 4 over the square root of 18. Of course, you already have this down here. 9 times 2 is 18. You don't have a radical sign here, so you don't write this here as square root of 2. You leave it alone because it was left alone. It doesn't have a radical sign. So now you have 4 over 3 times 3 times 2. And now you have 4 over 3 times square root of 2. Okay? So we simplified it just like your instructions tell you. Okay, then you go on and you have 4 over 3 times square root of 2 times 3 over the square root of 2 times 3 over the square root of 2, because remember, we want to get rid of the denominator, and there it is. And this, of course, is going to allow us to do it, but you're taking both terms up towards the numerator and towards the denominator. You're combining them. Okay, so now when you combine, you go straight across. 4 times this 3 is 12. You don't have a radical sign over here. So guess what? What are you going to do? You're going to leave the radical alone. And now you've combined these two, 12 over 2. Now you have these two, 9. Negative 2 times negative 2 is square root of 4. You already know that's a 2. But why don't we just leave it for now until we get to the next slide. Okay, now you're going to simplify this, and what I did here was this 3 goes into this 9 3 times, and this 3 is the lowest common multiple that we can find between the two. So we did this 3 and this 3, and this is 3 and this is 4. It's 4 times square root of 2, 3 times square root of 4. So it looks like it's simplified, okay, but it's not. 3 times square root of 4 is 3 times 2 times 2. You take this out because this is now what you call a perfect square. That becomes 4, and the square root of 4 is 2. So now you can get rid of the radical sign, which we did over here, and that becomes 3 times 2. And this is 4 over the square root of 2, and this is 3 times 2. So now when you get ready to do this, you have, this is just carried over from here. You now can simplify. 2 is the lowest common multiple. 2 then makes this a 3. 2 goes into 4 2 times. You have 2 over the square root of 2, and here you have 3 left alone by itself. There you go. Hey, congratulations. Check it off. You're done. Thank you for watching.